This review session, we are going to look at quadratics. I hope you're familiar with basic algebra like manipulating expressions, simplifying, expanding, and factorizing brackets with both linear and quadratics. Expanding brackets. How to expand two bracket ax plus b multiplied by cx plus d. For this we will use the keyword FOIL, that F represents the first term. First multiply the first term of both the brackets, that is AX multiplied by CX. You will get ACX square. Then outside terms, that is AX multiplied by D. ADX plus I represents the inside terms. So B multiplied by CX. You'll get BCX plus the last term. So that is B and D. So we'll get BD. Okay. This one is from the paper 12 ON 23. Verify the identity 2x minus 1 multiplied by 4x square plus 2x minus 1. That is nothing but expanding the brackets. First, let us take the term 2x. With that, we will multiply all the term in the next brackets. So, we will get 8x cube plus 4x square minus 2x. Then the next term is negative 1. With the negative 1, you multiply all the term in the next bracket. Negative 4x square, negative 2x plus 1. Now simplify this one. 8x cube, 4x square and minus 4x square gets cancelled. Minus 2x will be minus 4x plus 1. Okay. Next, finding roots of a quadratic equation. So to find roots of a quadratic equation, we have three methods. One is by factorizing. Next is by using quadratic formula. And the third one is by completing the square method. Now let us consider this quadratic equation, x square plus 5x plus 6 equal to 0. I hope you are familiar with all these three methods. Okay. First, let us solve this equation by factorizing. If you factorize x square plus 5x plus 6 equal to 0, what you will get? When when you multiply the two number, you need to get the product as 6, and when you add those two numbers, you need to get the sum as 5. Sum should be 5 and product should be 6. Okay. If you multiply 2 and 3, you will get 6. 2 plus 3 gives 5. So the result will be, by using factorization, x plus 3 multiplied by x plus 2 equal to 0. Okay. Next, by using quadratic formula. X equal to minus b, that is minus 5, plus or minus square root of b square, so which is 25, minus 4 multiplied by 1 multiplied by a is 1 and c is 6, divided by 2a, so 2 multiplied by 1. So on simplification, you'll get minus 5 plus or minus square root of 25 minus 24 is 1. Square root of 1 is 1, divided by 2. So x will be negative 2 and negative 3. Okay, here also we can write x equal to, so x plus 3 equal to 0 or x plus 2 equal to 0. On simplifying that, you will get x equal to negative 3 and x equal to negative 2 here. So the third is completing the square method. So x square plus 5x can be written as 2 multiplied by 5 over 2x plus, now add and subtract 5 over 2 the whole square plus 6 equal to 0. Now combine this, you will get x plus 5 over 2 the whole square. Then combine these two terms, minus 5 over 2 the whole square plus 6 equal to 0. So x plus 5 over 2 the whole square minus 1 over 4. We can write this is equal to 1 over 4. Then what is x plus 5 over 2? This is equal to plus or minus 1 over 2. So x equal to negative 5 over 2 plus or minus 1 over 2. On simplification, we get x equal to negative 3 and negative 2. Writing the given expression or the given quadratic function in the completing square format is one of the most repeated question. For example, let's do this question. This one is from the paper 11 ON 2016. Express x square plus 6x plus 2 in the form x plus a the whole square plus b, where a and b are constants. So x square plus 6x can be written as 2 multiplied by 3x plus, now add and subtract the square of this number, that is 3 square minus 3 square plus 2. Now combine these, we get x plus 3 the whole square minus 9 plus 2 will be minus 7. This is the answer. Easily you can score mark from this type of question. So these are the some of the completing the square question from the recent past paper. You try these questions. Let's do one more question, and this is from the paper 11 MJ 22. Express x square minus 8x plus 11 in the form x plus p the whole square plus q, where p and q are constant. So the given expression can be written as x square minus 2 multiplied by 4 multiplied by x plus add 4 square and subtract 4 square plus 11. So the given expression x square minus 2 multiplied by 4 multiplied by x plus 4 square can be written as x minus 4 the whole square. Minus 4 square plus 11, that is minus 16 plus 11 is negative 5. So x minus 4 the whole square minus 5. The next part of the question is, hence find the exact solutions of the equation x square minus 8x plus 11 equal to 1. So the given expression can be written as x minus 4 the whole square minus 5, and it's given this is equal to 1. This can be written as x minus 4 the whole square, which is equal to 6, x minus 4 equal to plus or minus square root of 6. Now what is x? X equal to 4 plus or minus square root of 6. So we can write x equal to 4 plus square root of 6, comma 4 minus square root of 6 are the solutions. The next topic is quadratic graphs. How to sketch a quadratic graph? Y is equal to ax square plus bx plus c. If a is greater than 0, you will get a positive quadratic like this. Or if a is less than 0, you will get a negative quadratic like this. The roots of the equation are the nothing but the x-intercepts. Suppose this is x-axis and the curve intersects at these 2 points with the x-axis, then these two are the roots. Okay, so we can find the roots by assuming the given expression is equal to 0. Suppose this is y-axis, then the curve which intercepts at y is known as y-intercept. Okay, and this is the turning point. And these two are roots. This is one root and this is another root. Okay, and this is the y-intercept. Completing the square helps us to find the turning point of a quadratic graph. If completing the square is of the form a multiplied by x minus h the whole square plus k, then h comma k is the turning point. Equation of line of symmetry is, for this curve, the line of symmetry is x equal to h. Okay, from the completing the square you can find out these two. This question is from the paper 12 ON 23. The equation of a curve is y equal to x square minus 8x plus 5. Find the coordinates of the minimum point of the curve. That is, you need to find out the turning point. So y is equal to x square minus 8x plus 5. First write it in the completing the square format. So y is equal to x square minus 2 multiplied by 4 multiplied by x plus 4 square minus 4 square plus 5 equal to x minus 4 the whole square minus 4 square plus 5 gives negative 11. So find the coordinates of the minimum point. What is the minimum point if the completing the square is given? See, here it is a multiplied by x minus h plus k. Okay. So minimum point is 4 comma negative 11. So here it's not mentioned like find the coordinates of the minimum point using the quadratic or completing the square method. Alternatively, you can use differentiation also. if you differentiate y with respect to x, you will get 2x minus 8, and finding the coordinates of the minimum point. So turning point is 0. So 2x equal to 8. So x equal to 4. When x equal to 4, what is y value? Y is equal to 4 square minus 8 multiplied by 4 plus 5. This is equal to negative 11. So 4 comma negative 11 is the minimum point. Okay, you can use any one method, whichever is convenient to you. Next, quadratic inequalities. To solve the quadratic inequalities, first rearrange it in the given expression, or the given expression in a positive squared form. That is ax square plus bx plus c is greater than 0 or less than 0 or equal to 0. Okay. Then find the roots of this equation, assuming ax square plus bx plus c equal to 0. Okay. Then sketch a graph and mark the roots. Okay. That is your third step. First step is rearrange the given expression like this as a positive square form. Second step is find the roots, and third step is sketch a graph and mark the roots. If the inequality is ax square plus bx plus c is greater than 0, then you want the region above the x-axis. Ax square plus bx plus c is greater than 0, then these two are the roots, x1, x2. Okay, let's take x1 and x2 as the root, and here the inequality is ax square plus bx plus c is greater than 0, then you want the region above the x-axis, that is this region. Okay, the solution will be then x less than x1 or x greater than x2. Okay, if the inequality is ax square plus bx plus c is less than 0, then you want the region below the x-axis. That is, you want this region. So the solution in this case is x1 less than x, which is less than x2. Okay. The next example is a curve has equation y equal to 2x square minus 6x plus 5. Find the set of values of x for which y is greater than 13. So this question is from the paper 12 ON 16. 2x square minus 6x plus 5. for which y is greater than 13. So this expression is greater than 13. Okay. First a step will be rearrange it in a positive squared form. That is, bring all the terms to one side. So 2x square minus 6x plus 5 minus 13 is greater than 0. Or 2x square minus 6x minus 8 is greater than 0. The next step is find the roots. Okay, let us factorize this one. We can divide all the term by 2 so that we will get x square minus 3x minus 4 is greater than 0. Let's factorize this one. X minus 4 multiplied by x plus 1 greater than 0. So the roots are negative 1 and 4. Okay, the critical values are negative 1 and 4. Let's sketch this one. This is negative 1 and this is 4. Okay. So this is of the type first type. Ax square plus bx plus c is greater than 0. Then in that case the solution will be x is less than the first root and x is greater than the second root. Okay. And we want the region above the x-axis. So we need this part. Okay. So the solution is x less than negative 1 and x is greater than 4. You can try this question of the similar type from the recent past paper. The next topic is discriminant. The discriminant is part of a quadratic formula that is under the square root sign. That is b square minus 4ac is known as the discriminant. Okay. If b square minus 4ac is greater than 0, the quadratic crosses the x-axis twice. That is, it will have two distinct real roots. It's greater than b square minus 4ac is greater than 0, then it will have two real roots. Two real distinct roots. If b square minus 4ac is equal to 0, then the quadratic touches the x-axis once. So it has one root, that is repeated roots. The third type is b square minus 4ac is less than 0. In this case, the quadratic does not cross the x-axis, so no real roots. So in the question, if it is given the quadratic has two real roots, then you need to take b squared minus 4ac is greater than 0. Or if the clue is given as the quadratic has no real roots, then you have to take b squared minus 4ac is less than 0. Okay. let us look at this example. A curve has equation y is equal to 3x square minus 4x plus 4, and a straight line has equation y is equal to mx plus m minus 1, where m is a constant. Find the set of values of m for which the curve and the line have two distinct points of intersection. So here it's given the line and the curve has two distinct points of intersection. That means the discriminant b square minus 4ac is greater than 0. Okay. So it's given the curve and the line intersects. So we can equate the curve equation with the line equation. 3x square minus 4x plus 4 equal to mx plus m minus 1. Okay. So first bring all the term into one side and find the roots of the quadratic equation. 3x square minus 4x minus mx plus 4 minus m plus 1 equal to 0. This can be rearranged as 3x square minus 4 plus m multiplied by x plus 5 minus m equal to 0. Okay, this is C. So it's given the curve and the line have two distinct point of intersection. So b square minus 4ac is greater than 0. So what is b square? B square is negative 4 plus m. So we can write this as 4 plus m the whole square. Negative square will become positive. Minus 4 multiplied by a is 3 and c is 5 minus m. And this is greater than 0. So 16 plus 8m plus m square minus 12 into 5. So 60 plus 12m. This is greater than 0. So m square plus 20m minus 44 is greater than 0. If you factorize this one, it gives m plus 22 multiplied by m minus 2 is greater than 0. So the critical values are negative 22 and positive 2. Negative 22 and positive 2. Okay. So what we require the b square minus 4ac is greater than 0. That means we require the region above the axis. So that means we want this part. So the solution is x is less than negative 22 and x is greater than 2. These are the some of the similar question. You try these also. So some of the questions are of the form b square minus 4ac is less than 0, and some of the form b square minus 4ac is greater than 0. Okay. So you need to remember, you need to do the 3 steps. First, rearrange it in a positive square form. If it's given the curve and the line intersects, equate both the line equation and the curve equation and rearrange it. Then find the roots and the sketch a graph and mark the roots. Okay. If the inequality is greater than 0, then you want the region above the x-axis. If the inequality is less than 0, then you want the region below the x-axis. In the exam, most of the time you will get a completing the square question, which is of 2 or 3 mark question you will get. And next, definitely you'll get one question from this quadratic discriminants. Okay. Which will be of a 5 to 6 mark question. Sometimes this quadratics will be combined with coordinate geometry also.